All right, welcome to Unit 2 review. This is over inequalities. So let's take a look at the first one. A number y is no more than negative 23. The key there is the word no more. So if it's no more, it would have to be smaller than. So if it is smaller than, it would be less than. So y is less than or equal to negative 23. The second one, 3 times a number p, that would be 3p, is fewer. Fewer would be smaller than, so we've got a less than. The sum of 6 and a number q, so 6 plus q, is at least 12. So it has to be 12 or bigger. So you're going to have a greater than or equal to. Twice the number m minus 6 is at most 16. Well, the biggest it can be is 16. 16 or smaller. So you'd have a less than or equal to. All right, let's go ahead and solve some of these. So on the first one, you are going to divide by 12. And you get x is greater than or equal to, I know it's going to be a negative, 156 divided by 12, I believe, is 13. I need to get my calculator out and check that. What you do then is you want to graph that, negative 13 in the middle, something bigger, something smaller, and it's going to be a closed dot, and it's going to be shaded to the right. On the second one, we have a fraction. To get rid of a fraction, you multiply by the reciprocal. So we've got 27 is less than negative 3 over 2 y. Well, our goal is to get that y by itself. So the reciprocal of that is negative 2 over 3. Put parentheses around that so it's a little bit neater, because the 3's cancel and the 2's cancel, and you're left with y. You need to multiply this side by negative 2/3 as well. If I want to, I can put that 27 over 1, cross cancel, and I get negative 18. The trick on this one is I was multiplying by a negative, so I have to flip the direction of that inequality. Now when I graph, I always like to have the variable come first, so y is less than negative 18. So I'm going to put negative 18 in the center, something smaller, something bigger. And this one is going to be an open dot, shaded to the left. All right, on this one, remember 2 negatives make a positive. So it's negative 16 plus m is less than or equal to 12. Our goal is to get that m by itself, so add 16. And I'm going to get m is less than or equal to 28. Put 28 in the center, something bigger, something smaller, closed dot. That's smaller, so it needs to be shaded to the left. When you are doing this, you need to have at least 3 hash marks, and they need to be evenly spaced, and they need to be labeled. All right, on number 8, we want to write an inequality represented by each graph, then describe using words what the solution set is. So the inequality here is going to be x and it's less than, because it's being shaded to the left. And I'm not going to use a equal to sign underneath there because it's an open dot, -1. And if I were going to use my words, that just means the solution is everything smaller than -1. And they're asking for 3 possible solutions. Well, the possible solutions here are anything smaller. So -2, -3, -4. Because anything smaller than -1 is a solution. Anything shaded is a solution. I could have put -7. I could have put -100. All of those are solutions. All right, number 9. Number 9 looks a little bit more involved. So on that one, I'm going to start by distributing, and I get 3w minus 12 is greater than or equal to -24w plus 6. Well, we need to get all of our w's on the same side, so I'm going to add 24w to both sides. When I do that, I get 27w minus 12 is greater than or equal to 6. Well, our w's are on one side. Now we need to get our numbers to the other side. So add 12. And I get 27w is greater than or equal to 18. Well, running out of room, so I'm going to rewrite that right here. 27w is greater than or equal to 18. I need to divide by 27 because that's my coefficient, my number in front of the variable. Those cancel. And 18 over 27 reduces to 2/3. And that is my answer right there. Let's go ahead and do the second part over here. I have 8t minus 6 is less than or equal to 12t minus 4t. Well, those can be combined because they're on the same side. So I get 8t minus 6 is less than or equal to 8t plus 6. All right, I'm already starting to see a problem because if I subtract 8t from both sides, those t's are going to cancel out. And I'm going to get -6 is less than or equal to 6. Well, -6 is less than or equal to 6. That is a true statement. So, infinitely many solutions, or you could put all solutions. Either one of those is fine, because no matter what I put in for t, it's going to be true. Probably all real numbers would have been the best thing, but I've already got that written down. All right, number 10, we have a compound inequality. We actually have three sides here, the left, middle, and right. I want to get that x in the middle by itself, so I'm going to add 12. And that would give me 9 is less than or equal to x is less than or equal to, nope, not equal to, just less than 34. So then I would graph that. I don't think I'm going to count by ones because there would be a lot of spaces there. So let's count by 9. What would be a good number to count by fives? 14, 19, 24, 29, 34. It's going to be a closed dot at 9, and I'm going to shade in between. The way I always remember it is that x is in between those two numbers, so I'm going to shade in between those two numbers. All right, on this one, we've got an or, so I'm automatically thinking it's probably going to be in opposite directions, but we're going to solve each one separately. So on the first one, I'm going to add 3 to both sides. And that is going to give me 2x is less than or equal to 0. Divide by 2. X is less than or equal to 0. Well, I need to do the second one as well. So on that one, I'm going to minus 4. And that's going to give me negative 3x is less than negative 12. I'm going to divide by negative 3. They're trying to trick you on this one because you're dividing by a negative. Remember to flip the direction. So we've got x is less than or equal to 0, or x is greater than 4. So 0, 1, 2, 3, 4. Well, x is less than or equal to 0 would be a closed dot at 0 and shaded to the left. X is greater than 4, open dot at 4, shaded to the right. And my prediction of them going opposite directions is correct. On number 12, subtract 16 from both sides. And I get negative 17 is less than x. I like to have it so the variable comes first. Makes it easier to graph. Well, if negative 17 is less than x, x has to be greater than negative 17. Negative 17 in the middle. Couple bigger. Something smaller. Open dot and shaded to the right. On number 13, I'm going to think of that negative sign down with the 4, so I'm going to multiply both sides by negative 4. And that's a 4. That's going to give me negative 12. And again, flip the direction of the sign. Those negative 4's cancel, and I'm left with just x. Rewrite it so that the x comes first. Negative 12 in the center. Something bigger. Something smaller. Close dot at negative 12. Shaded to the right. This one, I'm going to divide by negative 2. and I get x dividing by negative. I have to flip it. It's greater than or equal to -7, -7 in the center, something bigger, something smaller, closed dot at -7, shaded to the right. Number 15, we've got a compound inequality again. So I'm going to think of it as three sides. Subtract 4 from the middle, from the right, and from the left. And that gives me -2. Nope, not -2, +2. Greater than, that's where I got my -2, -2x, greater than or equal to 6. Well, I need to divide everything by -2. And I get -1 is less than x less than or equal to -3. I remembered to flip the signs. When you write an equation like this or an inequality like this, not an equation, an inequality, it's always better to start with the smallest number. Right, we can just go ahead and graph it too. -1. Actually, I'm going to put a couple extra hash marks on this one. I'm actually almost going to think of this as two inequalities. X has to be greater than -1, which would be right here. And then x has to be less than -3. If you notice on that one, nothing overlaps. So that one is a no solution. No solution. All right, let's do our last one here. On that one, I'm going to add 3. And I get x is greater than 3. Or divide by -2. And I get -2. Flip the direction of the sign. And I'm going to write it so that the x comes first, greater than or equal to -2. There is my solution. And this one is kind of a special case as well. Because if I graphed x is greater than 3, it's going to look like that. X is greater than or equal to -2. It's going to look like that. Oops, I just saw a mistake I made. Let's go ahead and fix that mistake. Kind of curious if anybody else saw that mistake. Okay, I was correct when I said -2 is less than or equal to x, but when I rewrite that, x is greater than or equal to -2. That is what I had. Oh my gosh, must be early in the morning. We're going to try this one more time. Flip the direction of the sign. That less than becomes greater than. All right. Now we're going to go ahead and rewrite that. There we go. So -2, -1, 0, 1, 2, 3. Open dot at 3, shaded to the right. Close dot at -2, shaded to the left. And they are going in opposite directions. Kind of proves to you that you need to work slowly and it's easy to make a mistake. All right, I will be adding a second video with some absolute value, but this should be enough to get you started. Thank you.